So what we're going to do is probably one of my more favorite camp activities that we do. Unfortunately, we can't do it in camp because, well, we can kind of gather together, but right now they're setting the number at 25. But I will tell you that almost every single time when we gather together, we have way more than 25 at camp. So we can't do it this year. Hopefully, we get to it in a little while. Hopefully, we'll get to more of these next year. Hopefully, things get better, right? So, what we're going to do is we're going to take, well, this one is called egg catch. Now, I'm not going to say you should be using eggs for this, okay? To practice, it would be smarter to use a golf ball. You could use a ping pong ball to test it, and you're going to need to be finding a spot where you can drop your golf ball or ping pong ball without breaking anything or causing any problems. Does that sound okay? This is a fun activity. It's great. And it talks a lot about Newton's laws of motion, specifically forces as objects fall. So here we go. So when we talk about forces, the force is not what Luke Skywalker has in the Star Wars movies, okay? It is the idea of a push or a pull. Those are the only two ways that forces are. They're either pushes or they're pulls. You're either pushing on something or pulling on something. If I were to hit the wall, technically I'm not pulling on the wall, I'm actually pushing on the wall, okay? If I'm moving like my fingers on a touch screen, if I'm using my phone, I'm actually pulling. I'm not really pushing, I'm actually more pulling things, okay? Just because of that contact. Now, lots of times with the pushes and pulls, you can change those. And we are all governed, for the most part, by Newton's laws of motion. And there are three key ones. We all know what they do. We might not know the names of them. I think I might have mentioned them. If you're a fourth or fifth grader, we've talked about it. We can go real quick over. So, inertia, or law one, objects in motion stay in motion, objects at rest stay at rest. So once you get outside and you get running, you want to keep running. Once you're in bed and you're at rest, well, I like being in bed and sleeping. Sleeping is good, okay? Some of you would like to stay in bed all day, and you'd probably be happy. I can see a lot of smiles on the faces there going, yep, I'm all over that one. Yep, I'd agree, okay? It's not until something wakes you up, either your body naturally wakes you up, too much sunlight, or somebody throws a bucket of ice on you, okay? Objects in motion want to stay in motion. My computer would stay here until something knocked it over, some kind of outside force. The second one is hard to understand when I say it, but it's easy to see, okay? The larger the mass of an object, the more mass, the heavier it is, the more force you need to move it, and the harder it is to get it going. And it'll accelerate, a little bit slower. Big, heavy grain trucks and trains versus smart cars and go-karts, okay? And three is for every action, there's an equal and opposite reaction. So for every time I punch my hand, okay, notice I punch, my hand rebounds a little bit, okay, but my hand goes this way as well, here, okay? So in a visual way, Newton's law one is inertia, resistance to change. Remember, you want to keep going when they slam on the brakes. Your body keeps throwing forward, the car stops, you keep going forward because you're already in motion, okay? Same thing like if you like to ride on roller coasters, as soon as you go straight, then you get thrown one way or the other on turns, okay? That's your body fighting back. Newton's second law of motion, notice we've got these two kids pulling rocks, heavier objects, more force to move, right? It's that simple. And for number three, for every action, there's an equal and opposite reaction. I like this picture down here because it really illustrates it easily to see what goes on. When this guy jumps off the boat, okay, notice jumps forward, okay, the action is jumping forward off the boat. When he jumps off the boat, the reaction is the boat goes the opposite direction. So if I jump towards you, I'm going to push my body and my motion backwards. It's kind of weird. If you've ever jumped off a boat or walked off a boat, you know that as soon as you push off, the boat goes backwards. I happened to do that yesterday. Hang on one second. Oh, kitty cat. There you go. Door was closed. Kitty cat needed out. Yeah, I know. People problems. All right. So yesterday I was walking downstairs and I happened to hit a piece of wood that was slick, and I stepped on it, and my foot, the rest of my body stayed put, and the rest of my body went forward. So as that went that way, my body went the other way, and it didn't feel very good, at least temporarily. It didn't feel very good. Okay. So for every action, there's an equal and opposite reaction. So remember, every time you punch the wall punches you back. So when we do the egg drop, when we would do this in camp, we'd use eggs. Please don't use eggs. That's a waste of eggs. I can't use golf balls. It's easier. Or a rock. That'd be fine. Okay, something that is about as heavy as an egg. You can find river rocks that are about the size of an egg, about the same mass as an egg. Use those. That'd be smart. Okay, so the physics of, wait a second, let me backtrack. Equal and opposite reaction. Let me change. My bad. I wanted to show one other thing. I don't know how many of you watched them launch the rocket a couple days ago. It was awesome, kind of cool. Just so you know, we're going to have an equal and opposite reaction here. You're going to have all of this power from the thrust going this way, right? And so if you push down with a rocket that way, your rocket is going to blast off into space. Space. And it was pretty ridiculously cool. Hopefully you watched the whole thing. The speed it got up to was pretty darn insane. Okay, so here we go. I'm going to show, whoop, did that wrong there. All right, there we go. So if I play this here real quick, we'll watch this. 9, 8, 7, 6, 5, 4, 3, 2, 1. Notice they're wetting everything down. And you've got to push off here. There you go. Liquid oxygen, hydrogen. Force going downward, rocket going upward. Action, reaction. Pushing down, going. It's fireworks, okay? Pushes down to kick upwards. The cool thing was, let's see if we can jump forward. I love how fast they ended up going. A ridiculous speed. Look at how fast they're going, 26,000 kilometers per hour, which is roughly 15,000 miles per hour. There, they hit 27,000 kilometers per hour. And what they did is they actually landed their rocket, that first stage rocket, back on that drone ship using equal and opposite reactions. Okay, using equal and opposite reaction. It's awesome, okay? I watched the whole thing. They lost the feed, which stunk that they didn't get to see the rocket landing. My other favorite thing in space was when they got there. Where's the guy and his dinosaur? Where is the part where he has a dinosaur? There's a part, did you see this guy right here who was the closest to the camera? He had a dinosaur, a little sparkle dinosaur. It was awesome. Let's see if I can find him. They have the sparkle dinosaur. It made me laugh. It's like, oh, he's in space and he's got a sparkly dinosaur. I guess that's what all spacemen do. So look at that, 27,000. Oh, that's where they lost the second booster. Now they're in weightlessness. And he had a sparkly dinosaur. Okay, so all sorts of really cool stuff. I hope, go back and watch it. It was really cool. It was the first time that the United States actually launched those things. And so when we go back to our drop, okay, when we hold something up high, we have what's called potential energy. Like it has the potential. So this board that I have screwed into the wall here has the potential or the possibility to fall and crash, okay, and make a gigantic mess. As soon as it starts falling, right before it hits the ground, it's going to hit its highest, what's called kinetic, or its highest motion energy, where it's going to end up causing the most damage, okay? So the heavier you are and the farther you fall, the harder you hit, okay? Think about that. So what you want to do is you want to, this is egg, I didn't change it. We want a golf ball or a rock, okay? And remember, it's going to bounce as well. So be aware that when it falls, it's going to hit the ground and bounce. So you want to avoid that as well. You want to catch a falling golf ball or a rock without breaking it, okay? You want to go as high as you possibly can without breaking it or doing any damage. Now, it's really tricky to do because golf balls and rocks will take impact pretty well. They're much harder. So maybe what you want to think is if you drop this on concrete or a sidewalk, maybe you want to see, can you do this without putting any damage into it? Because you know when you drop a rock or something, you could dent the concrete. Well, can you avoid doing that, or can you do that also without damaging your contraption? Okay, if you break your contraption, it's not going to work out so well. Usually when we do this, we have a really cool telescoping meter stick that can go up to like 17, 18 feet, okay? And when we do that, we drop the egg, we push a button electronically and it drops it, and it's hilarious, okay? Usually when we do this, okay, I'm gonna go here. I'll come back to that. So let me give you some ideas. Here are some ideas. I did this in slow motion. This was before I even started the job. These are some camp ideas. I actually worked the camp. So here are some different contraption ideas. Now, I don't remember which one worked the best. I think it was this one in the middle, if I recall correctly. And the reason why is it was taller and it was able to slow down the dropping force the easiest, okay? But the funniest video, or the best one to watch, is this one right here. So I'm gonna go ahead and play this one over here. I'm just gonna mute it because there's really nothing to listen to. So watch this one over here on the left. It's a lot of fun to watch. Here you go. So watch this one over here on the left. Notice it bounces off the balloon. Let me go back here real quick. Drop, 3, 2, 1, boom, drops. Now, great idea. I think this one was really good. The problem was when they missed it, they missed where they dropped it from and hit the balloon. And if you watch, it bounces, goes back up a couple meters. This was from about 10, 15 feet, and then hits that and cracks pretty good. Okay, it's always fun to watch stuff crack in slow motion. We can go down here to this one real quick. Let me move you guys out of the way here. Mute and mute. Okay, you can look at this one here. It's on stilts. It worked pretty well, except, again, the problem that everybody has is hitting the target. So here you can go and kind of watch it here. You notice the biggest problem, yeah, the slow motion didn't work right. So if you watch this, I'm going to kind of drag it. So you watch as it comes flying down. Look what happened, okay? It's over here on this side, all right? If they would have been able to get it here in the middle, would it probably have worked well? More than likely. The only concern I would have is they only had paper in the middle, and that egg's gonna come flying through it pretty hard, okay? So their biggest problem was that leg gave out, and notice it missed it to the side, cracked it and broke it. This one, this giant cone shape, I think it worked the best. And again, it's kind of a weird one. If you watch, the only problem they had was when we dropped it. It's really slow motion. Come on, egg. There it is. Okay. I goofed up the slow motion. So here's the problem. Watch when it comes in. Notice it's about to, okay? Good accuracy. But again, the problem, look what happened. It just missed to the outside. It just missed to the outside. And then it ended up becoming a splatted egg. So those are some good ideas. I liked this middle idea best, if I recall correctly. This one worked pretty well, but again, newspaper is pretty firm when you stretch it out, okay? So here is what you're going to get, okay? you're gonna get 1 or 2 sections of newspaper. And when I mean a section of newspaper, I mean, you know, this is 1 section to me. You could have 2, but try to limit yourself to 1 if you can. It'll be great, okay? Because we would limit your materials as well. 1 to 2 meters of tape. You won't need a whole lot of tape. You will need it to help reinforce some spots, especially where it's weak. Think about that. I'll be nice and give you 10 straws. You can use bendy straws. You can use regular straws. You can use whatever you like to use. Plastic straws work well. Paper straws will be great. They're a little bit firmer, but they'll bend and they'll create a weak point, kind of like a cardboard tube will. So if I had this cardboard tube, notice it's going to have a weak point eventually. If I bend it here, well, now it's weak right there, and we don't want that. If we can avoid it, we want to avoid weak spots. You could use 4 skewers, or you know, if you have like popsicle sticks, you could use 4 or 5 popsicle sticks. That would work. If you have a long, skinny balloon, you know, the ones that they make balloon animals, use those. Those were always great to use. If you look at these examples right here, they loved to use the skinny balloons. But there was one problem. If you notice the examples, especially this one right here, when it dropped, it always had the tendency to hit the balloon and bounce up and rebound, because balloons are elastic, like a rubber band. They're stretchy. So you need to be aware of that when you use the balloon. If you have a piece of like a nylon sock, go buy those cheap little nylon footy things that they usually use with like ladies' feet. Don't steal them from a shoe store. That's gross. Okay? And that's stealing. Don't do that. But you can use like a simple nylon sock. That is pretty good because it's elastic. It's netting. It's stretchy. It's kind of like a trampoline. But again, you stretch it, it becomes a trampoline. It's going to bounce and rebound. Okay? You could use a few pipe cleaners if you would like. That's a good one instead of using tape to brace things. What did this group do? This group, that group used pipe cleaners? No, this group kind of used pipe cleaners here in the middle. They kind of anchored their base of their cone shape with pipe cleaners to kind of twist it and keep it together tight so the egg wouldn't fall out. That's an idea to use, okay? And then you could have a couple pieces of paper. I would use cardstock or construction paper. Construction paper is a great idea. Cardstock's a great idea. If you have old like manila file folders, I don't have any handy, but you know what I mean? The file folders that, you know, you put things in, you could use that. I'm looking at, I've got a paper sack here. Great idea. Try to limit your materials. Try to make the most efficient rock or golf ball catcher that you can by using the least amount of materials. Because when you start to add too much to it, you actually cause problems. You'll actually end up missing. And the only reason I know this is because in high school physics, when I did this as kind of one of our things, we could design it a little bit more complex when we were in high school. I had one with a beach ball that was in the middle of a wooden crate. Well, what was my problem? It caught it every time because the beach ball was deflated. But the one problem I had, I missed the drop. I hit the edge with the wood. I should have put that wood down lower. The one thing I did do, I had to do this for 2 people. Somebody else just had a box full of packing peanuts and foam chunks. Theirs worked just fine. Number 1, I aimed and got it correctly. And number 2, it's just simple. So I actually over-engineered it. I overthought it. I made it too complex when I should have kept it simple, like a box of foam peanuts to catch an egg. And this is on top of like a scaffolding ladder that they would use in like the scissor scaffold that they use in schools to change the light fixtures. That's about how high up we were. We were up about I was up on top of this thing wobbling above our school, probably about 15, 20, 25 feet roughly. So it was a little unnerving. The wind was blowing. I don't like heights anyway. So if I were at my house, I would use my deck. I actually happen to have a 2-story house that I could actually reach out, and I don't have like an overhang here. I could actually drop it out of my window if I could do that. If you have that ability to do that and test it, great. I know that when I was testing this, I remember in high school when I was testing this to see if it worked. I had a house with a flat enough roof that was a 1.5 story. I was actually on top of the roof, hanging over like where the peak comes together. I was actually holding it in practice, dropping it from a 1.5 stories down, which was pretty impressive, and I managed to do it pretty well. So those are some ideas. Those are some thoughts. Good luck with this, ladies and gentlemen. Give it your best shot. Try it out. See what you can come up with. Next week, what we're going to do is I will be using my computer to show you what's called Tinkercad, which is an online program where you can do 3D modeling. And when you do the 3D modeling, it's actually something that, and I was talking to Matt, the other science guy, you guys will have, and you should have access to 3D printers in your buildings next year. So anything that you design, you can actually turn into something that you 3D print. It's really cool. And if you don't believe me, we did this with Dill Rodell and Southern's camp. One girl actually took the time to build a 3-dimensional die. So 1, 2, 3, 4, 5, 6 that could actually roll. We 3D printed it and sent it to her. I think one girl built the Master Sword from Zelda. A lot of really cool stuff you can do. Okay, so we'll